Morning and welcome to this session of the Data Doctor. Today we're going to talk about the order of operations. And the order of operations is probably the single most important thing you have to understand uh, when you're using Tableau and when you're first learning Tableau. Today we're going into a little more depth than we might have gone in the past. We're going to take a look at how that order of operation affects your calculations. Well, first let's talk about what the order of operations is. It's simply the steps that Tableau goes through, the sequence it goes through, if you will, every time it creates a worksheet. I like to use a 10-step model. I know there are other models out there, but this is the model that I like to use. It's a 10-step model. The first two steps, extracts filters and data source filters, are executed at the workbook level, and they limit the amount of data going into the workbook. And with less data in the workbook is going to perform better. Now, all the remaining steps, step 3 through 10, are operated at the worksheet level. And each worksheet has its own data table, its own data structure, if you will. And that data table is a subset of the total data that you entered into Tableau. Now, steps 3 through 5 create the structure for that data table on that individual worksheet. And then the remaining steps, steps 6 through 10, just load values into that data table. We do some math, and then we decide what the viz is going to look like and make the viz. If you think about how you enter data into Tableau, it can come from a variety of different sources. It could be a flat file, or it could come from a database, or it could be several files that you've connected together somehow in Tableau. But you start with that file, and as you create each worksheet, you're going to create a data table for that worksheet. You can kind of think of it like it might look like an Excel spreadsheet. It doesn't really look that way, but it's the same idea where you're taking headers and you're applying them on the rows and the columns to create a structure for that data table. And as you apply filters, it further limits the structure of that data table, and it creates a structure for the subset of the total data that you're going to use on that worksheet. After you create the structure, you then load that data table with values, and we do some math, and we decide what the viz is going to look like, and finish up the total worksheet. Now today, we're going to use the Superstore data set. You know, I use the Superstore data set all the time because you have it. That's the same data set you got when you got your copy of Tableau, so you can follow along with it, or you can recreate this yourself. The Superstore data set, just remember these values because we're going to make some changes along the way, and you're going to see how it affects the overall size of the data table. There are 800 customers in that data set, a little over 10,000 records, and it's $2.3 million worth of sales. So just kind of put those in the back of your mind, and we'll come back to those in just a moment here. I want to take a look at the first two steps, steps 1 and 2, where we're looking at extract filters and data source filters. Now, they're going to operate at the workbook level. And what these two filters do is they remove data, or as you upload your data, as you upload the data set into Tableau. And if the data set is smaller, the workbook is going to have improved performance. They're very easy to use. Let's take a look at how we might use one here. Here's that data tape, that simple data source again. I'm going to go out here, open up the data source tab, and you can see here I can come up and I can add a data source filter. All I have to do is come up here and click add, and a window opens up, and we get to choose the type of filter that we want to add. So we're going to add a filter. I want to add a filter on order date. Okay. And now this should begin to look familiar to you because it's the same type of structure you use when you add dimension filters. Okay. I want to add a filter on years, and I only want the 2023 data. Okay, and you see now this box says for the year of order date, we're only going to keep 2023. All the other years are going to be gone. Okay, so we're going to accept that. And now, when we come back, we can see we no longer have 10,000 records in that data set. There's only 3,400 records in that data set. And there isn't $2.3 million of sales. There's only $745,000 worth of sales. And that's what represents all the data that was in 2023. Now, if we come out here and I just want to put order data out here, I can put order data, and you can see it's just 2023. There is no other year left in the data set. Okay, well, that's the most basic way that you can apply a data source filter. But I would also like to go out and think about putting in a dynamic filter that you can use as a data source filter. And the filter I want to look at here is I want to take a look and only look at customers whose total value is over $10,000. Okay. And I can write this LOD expression, and this expression merely says for each customer, sum all of their sales. And then I make it a Boolean by comparing that to 10,000. You know, if the sum of 10,000 is over the sum of sales is over $10,000, this expression is going to return a true. Otherwise, it's going to return a false. And you can see it here. That's a true false filter. Now, it's an LOD expression which can be determined at the time the data is loaded. Let's go back out to that data source. And I'm going to take the filter. We had this filter out here for your data source. I'm going to remove that. Okay. I want to replace that filter. I'm going to put in a different filter now. This is the expression we just generated. And that's that LOD expression. I'm going to say, yes, that's the one I want. And I only want to look at the true values. Okay. So if the total value of that customer is over $10,000, I want to keep them in the data set. Otherwise, I'm going to remove them from the data set. And I can do that and say yes. And now we can go back out and we can take a look here. And instead of having 800 customers, there's only 21 customers that have a value of over $10,000, and their total sales is $275,000. Well, that's fine in the static set. But the next time we update that data set, there might be more data. We've got another month's worth of data. And that filter, this LOD expression that we calculated, will automatically update, and it will adjust to the new data that's in there, and that distinct kind of customers will probably go up as a result of that. Okay, I want to spend the rest of the time today looking at the steps 3 through 10 in the order of operations. And those steps work specifically on each individual worksheet. We're going to be working at the worksheet level. And I want to start by talking about steps 3, 4, and 5. That's where the structure for the individual worksheet is created. Okay. And step 3 is context filters. Step 4 is the creation of sets, fixed LODs, and the top N. And step 5 are dimension filters. Now that's where the structure for each one of your data tables is created. And it also is the area where we see the most frequent errors by users. And I want to just start, once again, we're going to start with a very simple example where I want to take a look at a fixed LOD and how it reacts to changes in a filter. Now, the fixed LOD that we're going to look at, just a very simple, I wrote it like this. It's just at the category level, fixed category and year of order date, sum of sales. So if we take a look here, here are sales by subcategory and category, and the total sales for furniture is $754,000. And this expression, the fixed LOD, shows up at that same value, $754,000 is fixed. For office supplies, it's $731,000, and for technology, it's $839,000. Okay. Now you can see here, I've also got a filter that I'm going to apply on subcategory. And right now, all the subcategories are shown, and I've got the subcategory, and you can see it's a grade filter. It's a grade filter because I've already placed it in context. And you do that here by, I can remove it from context and it becomes a blue filter. I can put it into context and it becomes a gray filter. Now, as a context filter, it's going to be applied before we calculate the fixed LOD, the sets, or the top N. So as a context filter, when I come in here and I filter out bookcases, you can see that the bookcases get filtered out and the total of those values is $639,000. And you can see now the fixed LOD for furniture is 639 because we took bookcases out before we calculated this value. Okay. By the same token, I could have come in here and I could have said, well, wait a minute, I'm going to use this, I'm going to remove it from context, and I'm going to use it as a dimension filter that's applied after the LOD is calculated. And oops. And now when I do that, I'm going to take out bookcases, and you can see the total of those three values is $639,000, but our LOD is still at $754,000. The bookcases were filtered out after this LOD is calculated. And I could take out appliances here, and we could see the same sort of thing going on. $623,000 for office supplies, but the LOD is still at $730,000. So very simply, if you want the filter to be applied and affect the LOD, then you apply the filter in context. If you want to filter after the LOD has been calculated and not affect the LOD, you use it as a blue filter, as a dimension filter. Well, let's see what happens when we take a look at how it affects sets and top end calculations. Now, I've created a set here in subcategory. And the subcategory set I created using this tab here for top end. I want to see the top end, and I want to see based on this thing, which is a parameter that I've created over here. It's select end for top end, and I've set it at 5. So we're going to get the top 5 values because we're going to see what's in the set. We're going to see the top 5 values, but once again, we're going to use the subcategory, and we're going to filter the subcategory first in context so that it's filtered before the top end are calculated. So you can see here, the top 5 include chairs, tables, binders, storage, and phone. Well, I'm going to just filter out chairs and tables. And you can see when I do that, I still end up with 5 values. We wanted the top 5 values, but you won't see chairs or tables because we filtered those out before the top end were calculated. Okay. I could also have done this by filtering chairs and tables as a dimension filter after the top end were calculated, and there's only 3 left. So once again, if we filter before the top end and the sets are calculated, we do that in context filters. If we want to filter after, we do it as a dimension filter. Well, you probably knew that, but what else can we do with this? We get a lot of requests for people will say, well, I want to apply a filter on a dimension, but I want it to apply sometimes and I don't want it to apply at other times. So I made up this little example. We can do that by leveraging the order of operations here. First, I've got a calculation here. This is the same fixed calculation we used before. This is the fixed category, year of order, date, sum of sales. That's the same category, the same that we used before. And also, I've come back in and I've made a calculation that's going to calculate the percent of sales, the percent of total sales, and I'm going to use the sum of sales, which is this value here, divided by the sum of the fixed category, which is that LOD that we have used before. And I just want to drag this over here and get it a little closer to what we're doing so you can see it. We're going to start with all the categories checked off here. And you'll notice that I've got the subcategory filter as a blue filter. I'm filtering after the LOD is calculated. So we can look here and we can see that the total for furniture is $754,000. The fixed value is $754,000. And bookcases represent 15% of that total, and these will total 100%. Okay. Now, what I'd like to do is I'd like to filter out bookcases, and I want that to affect the numerator, but not the denominator. The denominator is our fixed calculation. So I'm going to filter out bookcases. And you can see bookcases have been filtered out. So the total sales for furniture is $639,000. But the fixed value hasn't changed because we are filtering that after the LOD has been calculated. So now we can see that the total for furniture without bookcases is $639,000, and it represents 84% of the $754,000 total fixed value for furniture. Now, we were able to do that because we were using the LOD expression is calculated before the filter is applied, but the filter is applied against subcategory, which affects the sales. So that's why you see the difference here, and we're able to have that dimension filtered for the numerator, but not filtered for the denominator. Now let's take a look at another example that comes into play, and this one is where we really have to leverage the order of operation. And we're going to take a look here at a case where what I'd like to look at is I've created this LOD expression. I want to look at subcategories where the total profit is over $5,000. So I've got a condition here based on this LOD expression. I only want to look at categories that are over $5,000. And at the same time, what I would like to do is I'd like to look at the top N subcategories. Okay, and I want to take a look here on subcategory. You can see here it's limited here. It says it's top N by sales, and we did that. I want to edit the filter here. We did that by right here on the top N tab. I want to see the top N by sales or the top 5 by sales because I've got that N set to 5 in this parameter. And I'm just looking at the year 2021. Now I'd like to apply those at the same time, but you can see what I've done here. I should have 5 categories, and I should have nothing with profit less than 5,000. But you can see that's not how this worked out. I've only got 4 categories listed here, and in this category, which is office supplies or storage in the office supplies category, only has profit of $3,500. So something's wrong. It didn't work. Well, what's happening here? Well, what's happening is that sets, fixed LOD, and top N are all determined in the same step of the order of operation. And I can't separate them out. That's what's going on here, and that's why this is wrong. I can't separate them out because they're all happening in that same step. So I have to find a different way of finding the answer that we want. So here we're going to once again leverage the order of operation, and we're going to use a different type of calculation. I'm going to use a table calculation on rank to determine the top 5, and that's determined in step 10 of the order of operation. We're going to see that in a few minutes here, but it's determined in step 10 of the order of operation. But I'm still going to keep this LOD expression. I'm going to use that as one of my conditions. So I've got set as a dimension filter. I've got that I want profitability greater than 5,000. And then I'm going to create a ranking function based on the sales that looks like this. And this is just a simple ranking function. It just says rank unique. I want to rank the subcategory sales. It's for each subcategory, I want the total sales, and I want to rank those descending. And then I've come back and I've also created a filter based on that ranking. And if the rank is less than that parameter that we're using to calculate the top end, which is set at 5. I want it to be true, and I set that equal to true here. Now, when we do that combination, we can get a ranking of the 5 categories, and all of them have profitability against greater than $5,000. Well, here was a case where if we just went through and we tried to use a top end calculation and the LOD expression, we couldn't do it at the same time because they were in the same step of the order of operation. But we had to come back and we had to realize that, oh, I've got another option later on in the order of operation that will give us the answer that we want by using a ranking calculation. Now I want to move on to the last the last 5 steps in the order, and that's where we load data into the data table. We do some calculations, and then we create the viz that you want to see. And we're going to focus on just 3 of these steps. We're going to include step 7, which is the include and exclude function. Then we're going to look at 9, which is grand totals and subtotals. Then we're going to look at table calculations, because those are the steps that use calculations. And we're specifically looking today as how the order of operation is going to affect those calculations. Let's take a look at the include and exclude statements. They're the other 2 type of LODs. The include and exclude represent about 20% of the total number of LODs that are written. About 80% of them are fixed LODs, and we've already talked about those. About 15% are include statements, and the remaining are exclude statements. Well, include statements, I like to think of them as setting a limit for at the level of the aggregation as we drill up in a hierarchy, and exclude tells us to use the next higher level in the dimensions that are available on the viz. Now, it's important to remember that these 2 LOD expressions don't operate on the structure of the data table. They operate on the value of the data table itself. Okay, I want to look at this one first. And we're going to look at include, always a good place to start. And we're going to take a look at this value that includes the state, and we're going to take a look at the average here. Got several here. I want to make sure I get the right one. And all this says is include the state or the province and the average sales. And I want to show you how include works. Well, I said include sets a limit at which the average is going to be calculated. So when I'm at that limit or below, you'll see the simple average, and this is just the simple average that you get from Tableau. You just say, I want to see the average sales. The simple average and the value that comes out of this expression, the average at the state level, are the same value. Now, they're not going to total the same because this is the average of the individual records, and this total is the average of the individual records. This is the average of the records at the state level. Now, it's interesting because when I go up to the next higher level, you can see the difference. Now, here, the simple average is the average of all the records broken down by state, where in the include statement, this is the average of each of the states, the average of the values for each of the states. Okay, let's take a look at what happens when we look at exclude. And we're going to go to the next set of values, and I want to look at the exclude, which is the same expression. We just changed this for exclude. We're going to exclude the state and the province. And what that does is says, okay, in the viz that you've got, you'll see the value of state and province. Don't use it in this calculation. Go to the next higher level, which is the region. So the average at the next higher region is this 215,000. 215,000, and you can see it's the same for every state as it is down here in the total. Now, the interesting part comes when I do this. You can see that I can get the average of each state, but they're not going to total. That's one of the properties and one of the things that happens with exclude statements. Well, how would you go about using these? Very often you're asked to form a bullet chart. You say, well, how do I form a bullet chart? I never can remember what to do, and what do I put on the dual axis and the like. Well, we've just calculated the 2 components. The 2 components are the include value, which is going to form the lines, This is including the state, and the exclude value, which is going to be the same across all the states. So I can use include and exclude right here to form this bullet chart without having to remember any special type of calculation along the way. Okay, I want to move on now to totals and grand totals and subtotals. And it's real important to understand how these are calculated inside Tableau. It's totally different than what's done on a Excel spreadsheet or a Google Sheets. You know, you're used to working on Google Sheets or Excel spreadsheets, and you got a long line of values, and you're going to total that line, and you're just going to add up those totals. In Tableau, what actually happens is that grand totals and subtotals are calculated in a separate module within Tableau overall. And it works on the data table level and applies the filters and any conditions that you have defining values in that data table. And it recalculates all of those as a total, not as an individual line, but as a total or as a subtotal. So it's not going through the same type of calculation that you would in Excel. And that's why sometimes you run into these differences. Now I'm going to show you how you can use basic grand totals and how you use them. And then I'm going to show you how some advanced features. But I'm also going to tell you how you can find out more in some other articles that I've written along the way. We take a look at just the basic totals, and I'm going to take this off just to show you how I like to do that. We're just going to remove those. I'm a drag and drop guy. You can go up here to analysis, and you can drop the totals in, and you can put in the totals and the subtotals here off the analysis tab. But I'm sorting here. It is totals, and you can show the grand totals and the subtotals and the columns and everything. I'm a drag and drop type of guy, and I prefer to do the totals, and I prefer to drag them in, and I'm just going to drop the subtotals in there. And you can see when we drop the totals in and the subtotals in, the default is to sum. It sums the values. So the sum of those is 162, and the sum of all those is 154. But you may not want that. You can change that by we could use the average, and now we get the average value. And if we wanted to go across the other way, across this way, we could see the average value going across and a down. And you can see when I change this, and it's important to understand this, when I change the total using, it affects both vertical and horizontal. So now I have the minimum value for the total, and here's the minimum of 15,090. And across this way, it's 15,090, and here it's 20,037. So now we have the minimum value shown in the table. And that's good. You can use those. You can't use the totals or the grand totals in a calculation, but you can get totals that way, and that's fine. Sometimes, though, you want values that you just can't get out of that type of out of what's built into Tableau. This example here gets into some what we call custom totals. What I'd like to do is first I'd like to calculate the average or the percent of total for the individual subcategory versus the overall total. But on the at the category total, what I want is the category total compared to the overall total. And you can see here, if I just go through the normal sequence that we go through, this is going to total 100. I do want those values, but I don't want that to total 100. So I've used a technique here that's a little more involved, and I'm going to explain this. Let me just spread this out so we can make it larger and you can see it a bit better. All this total does, and let me just do this. All this first expression does is it takes advantage of a property of the grand total and subtotal line. And at the grand total and subtotal line, two things are true, and some of you have probably seen this written as if size equals 1, then do whatever. And all that does is say, hey, in the total line and the subtotal line and the grand total line, we're going to tell you what to do. And you can do that, but once again, as you just saw when we were using totals and grand totals, you're locked in that the same type of calculation is done on every line when you do that. Here, I want to do something a little different. Here, I want to say if the subcategory minimum does not equal the subcategory maximum, and that is true in the subtotal line and in the total line. All this says is if it's a subtotal line, and we're talking about using subcategories, so we're looking at this line right here, then what I want to do is I want to take the category total by year, and that's just this fixed LOD at the category and the year level, sum the sales, and divide it by the overall total for the year. Every place else, in all these other lines, I want you to take the subcategory total sales and divide it by the total for the year. So I get the same values for the individual subcategories, but the total now is the category total. Now I show you this and you say, well, you might be able to get this another way, and that's true. But you can do this at multiple levels. And I'm going to show you out on my blog where you get to my blog. There's a whole blog piece written on totals and subtotals. And I take this down to at least one, maybe two more different levels and show you how you can get totals at varying levels within a hierarchy. I want to move on now, and I want to talk about table calculations. And you could do a whole hour on table calculations without any trouble at all. But today we're just going to talk about the effect on the order of operation and where it happens in the order of operations. Table calculations are last in the order of operations. Okay, it's in step 10 of the order of operations. Now, it's important to understand that they're done last. So anything that I've done before the table calculation, like using fixed LODs or anything that I've used before, I can use in the table calculation. But because they're last, I can't take the result of a table calculation and use it in anything else. And this most often comes up where people want to say, oh, I want to fix the value of a table calculation. I want to use it someplace else, and I can't use it in an LOD expression. That's right. You can't use it in an LOD expression. Have to find a different way around it. Now, there's another thing that's important to understand. The table calculation is done on the table, the data table, for a specific worksheet. And as we talked before, each worksheet has its own data table. So what you've done on one worksheet and its data table isn't transferable to any other data sheet, any other worksheet. They have separate data tables. Well, I'm going to show you how we can do some basic calculations, and I'm going to show you how we can nest table calculations inside one another. And then finally, I'm going to show you how you can use an LOD inside a table calculation. This is just a very straightforward calculation that you've probably seen more times than you want to see, because it's sort of like the default for teaching. You start with sum of sales, and I can come in here and I can make this a table calculation, do a quick table calculation, percent of totals, and I get the percent of total, and you'll notice immediately that it's calculating the percent of total across, we talk about scope and direction, across the table. The direction is across, the scope is the table. Not what we want. We can open that up. We can compute down the table instead of across, and now we got the percent of each subcategory for the total year, and that's the percent of total. Okay, that's fine. It's easy to use. We can also take the results of that and nest it in another table calculation. And this one I want to look at here, the percent of total that we just looked at. This is the formula for it. That's all it is. And you can find that formula very easily. I can take this value. You can see we just did this with a quick calculation. I can take this and drag it across. And you'll see now it's called calculation 2. And if I open this up where I find calculation 2, well, let's find it the easy way. Okay, we'll find it the easy way. There it is. Calculation 2 is that same calculation we were just looking at. Okay, that's how you can, and I use that all the time to get started writing my own table calculations. Okay, I can take that calculation and I can use it and nest it inside another table calculation. Now, what we have to know about table calculations is that the argument for a table calculation has to be aggregated. Okay, we're not working at the record level, we're working at a higher level, the visual level that you see on your chart, and those are all aggregated values, so that has to be aggregated. But the percent of total is aggregated. We already made it, and you saw how it was aggregated. So we're going to take the window sum of the percent of total from the first to the current record. And I wrote it this way. I could have written this as a running sum and done the same calculation, but I wanted to use this to show you the start and end. This first says start at the first record and continue doing this window sum to the current record or the next record. So all that says is, look here, I'm at the second record, and I want you to take this value, this thing here, this percent of total, and starting at the first record of that, I want you to go to the record where I am, which is the sum of those two values. And then I go to the third record down, the third row, and we add in the 3.05, and then the fourth, and we add that in, and so on and so forth. So we can use that to further aggregate a table calculation. We can nest a calculation inside a table calculation. In this case, we nested a table calculation inside a table calculation. We can also come back and we can nest an LOD inside a table or we can nest any type of calculation inside a table calculation. But in this one, we're going to use an LOD expression. And very often we get a request from a user out there. They want to do some ranking and they want to see the effect of how a category, and in this case, we're going to talk about subcategories, we're going to talk about segments, and we're going to talk about the year. They want to see how that's changed over time. Well, we need to know what those values are. And we're going to start by calculating those as an LOD expression. So here I've got an expression, and if you were to say this in words, you'd say for each year and each segment and each subcategory, for each combination of those three dimensions, total the sales. And I'm just going to show you what that is here. And that's what those values are. That comes from our LOD expression. Then we can come back and I can take that LOD expression. I can say, okay, I want to rank those. I want to find, descending value from the largest value to the smallest value. I'm going to take that LOD expression, put it in here, but I have to aggregate it because LOD expressions aren't aggregates in themselves. I have to aggregate it. Then I take that in descending order. Now I'm just going to do a little magic here to unhide some values. And that gets the values that you see here. Now I want to show you how we calculated that. The default is to calculate across, but once again, we wanted to calculate down the table. So we can change that by going to this point and editing the table calculation in terms of scope and direction. And we've done that, and then I just added some color to it. And this is nothing more than saying, look, if the rank is 1, change it to gold, otherwise it's blue. And that's all I've done to highlight what's going on there. Okay. Today we looked at the order of operation. We looked at how you can leverage your operation to do some advanced calculations, things that you initially thought, well, I can't do that. That's not going to work. I mean, first we looked how to make a dynamic data source filter, and then we started taking a look at how we can use, we can leverage the order of operations so that we can put we can make a dimension respond to a filter and at the same time have that same dimension not respond to the filter. And we looked at doing some custom grand totals and custom subtotals, as well as what we can do with table calculations. The only way you're going to learn how to use this is by practicing and by doing it. So I'm going to suggest that you do that every chance you get. Everything that you've seen today is already out on my blog. You can go out to my blog at jimdehner.com and you'll find it out on the blog. under order of operation. The workbook that we used is already out on my Tableau public site. You can download it from my Tableau public site. Everything I've got out there is completely available to you. Thank you for your time. I hope you enjoyed it and hope to see you again next month. Bye now.